1.3, solve linear equations by combining like terms and using the distributive property. Okay. So we got terms, like terms, and coefficients. We use these three terms quite a bit, not only in this class, but pretty much all the other classes as well. Terms, this is the value in a math expression separated by addition or subtraction. But it's important to remember the addition and subtraction, specifically on the left of the term, is the sign of the term, either as positive, which is addition, or negative, which is subtraction. So if I said, if we looked at a term and I said, well, is the term positive or negative, you would look to the left of that term and see if it's addition or subtraction as its sign. Like terms, that's when we got a math expression that have the same variables, which have the same corresponding exponents as well. That's true. So not only do they need the same variables, you'll look more into the exponent thing in 1010. But yeah, for now we're pretty much going to be looking specifically at the variables alone and not necessarily the exponents. Well, I forget in some cases. So coefficients, a coefficient to base numbers of a term. Oh, it's just a number. And yeah, it takes the operation as its sign. A coefficient is a number multiplied by a letter. Base numbers of a term. I'd have to think about that a little bit more, but I would say more that it's a number that's being multiplied by a letter. Let's look at some examples on these so we can kind of clarify some of this vocabulary like this. Again, it's important for us to understand this stuff because we're going to be using this terminology quite a bit. Now, these three expressions are full of traps, not on purpose, but because they're common mistakes that students make on tests and quizzes and things. So this first one where it shows a negative x, we would need to think, well, what is the coefficient of x right there? And a lot of students would say, well, there isn't a coefficient. Well, there is a coefficient, you guys. It's just not being shown. All right, so that coefficient of x, we did talk about these last time. It is a phantom 1, you guys. Now, it's not just a 1, by the way, because remember, it's going to take, that's not an operation right now. It's just a sign. But for this one, the coefficient actually is just a negative 1 right there. Okay? Now, this next expression, we got 8 minus x. So, again, it's going to work the same way, but now it is an operation. The sign of the 1 is an operation. So the coefficient of x in this case is this negative 1. The 8 is not related to it because it's separated by that subtraction sign. So the 8 by itself is a whole separate term in this specific expression. Now, and then finally this last one where it's just x, again, it's just a phantom 1, you guys. And if you need to see that phantom 1, use it and like draw it in when you guys are doing these types of problems because the one coefficient, which is sometimes a phantom 1, is actually pretty crucial when we start combining these types of like terms. So here's the large expression. It's pretty big, and we're asking for all the terms, like terms, and coefficients. Well, the terms, just everything separated by addition or subtraction. So I'm going to start farthest to the left, and I may need the space, so I'm going to show this is 4x. The next term is a 6. Those are commas. And then the next term is a positive 2x to the power of 2. And again, notice I'm not using the positive sign on these because when numbers are positive, we don't need to show it for an individual term. And then the next one, again, we would look at this term here as not just 9, but negative 9 because it's that minus 9 right there. So it's a negative. The minus becomes the sign of the term. And same with this next one. It's not just 5x to the power of 2, it's negative 5x to the power of 2. And then I got a 12x. Oh, sorry, I almost missed it right there. It's a negative 12x. And then a 4. And then negative 5x. And then positive 3x to the power of 2. And that's a 2. So that's all the terms. Quite a bit on that, right? 4, 5, 6, 7, 8, 9. 9 terms right there. It's pretty good. But then it says to identify all the like terms, and it looks like, if I'm seeing this correctly, that we should have 3 different sets of like terms right here. So I'm going to start with the 4x right here. Now, remember that not only do the letters have to be the same, but the exponents of the letters also have to be the same. So where we do find some of these terms to have x to the power of 2, it's not actually going to be a like term with just the regular x terms. So I'm looking, and I can scan this expression here for any other terms that have x's, but not just x's, like, scanning it from left to right, I see 2x to the power of 2. But it's got a power of 2 right here, whereas this 4x is not showing a power for the x. It's a phantom 1, by the way. So I would continue scanning this, and then I get the negative 5x to the power of 2. Again, it's power of 2. And then I come upon this negative 12x right here. So some of the like terms listed, I've got 4x, and then also a negative 12x. Those are like terms. And continuing to scan from left to right, I got this negative 5x. So that also needs to be listed with the x terms. Now I just started with 4x because it was farthest to the left. It doesn't matter which one you start with. Next I'm gonna look at the 6, and that's a positive 6 right here. These are considered constants because they're just numbers. They don't change. They're not being multiplied or divided by anything. So I'm going to start with the 6, right? That's a term. Are there any other like terms with the 6 that are just straight constants? No x's, no exponents, no nothing. It's just a number. Yeah, there's that negative 9 right there. But also, again, scanning from left to right, I got this positive 4. And I just need to show that as a 4 right there, not with the positive sign. Well, that leaves us with only the x to the power of 2's. And starting as far to the left as we can go, I got a positive 2x to the power of 2. And then also a negative 5x to the power of 2. And then finally, this positive 3x to the power of 2. Now, it's important for us to identify these like terms because we can combine them into individual terms, and we will, which I think we've seen a little bit of, but we'll do more here in a moment, okay? Now, listing all the coefficients, I don't want to consider any of the constants. They're not necessarily coefficients, though you could consider them. But if it's just a number by itself, I'm not going to consider it a coefficient today, all right? I'm just going to be looking at any terms that have letters or variables, in this case, x's. So just to start off, I'll start with the x's themselves. So I see I got a 4x, so the 4 is considered the coefficient. And then we got a negative 12x, so that coefficient would be negative 12. And then next up, those are commas. Next up, I got negative 5x, and the coefficient would be negative 5. But continuing with the x to the powers of 2, because they can have coefficients as well, there's that 2 right there, 2x to the power of 2. Negative 5x to the power of 2, so that's negative 5 is the coefficient. And then finally 3x to the power of 2, where 3 is the coefficient. All right, so that lists all the coefficients that we need in this problem. And you guys should be slightly familiar with those at this time. So we're not going to look too deeply into those in the future, but when I say coefficient, it's important for you guys to know what I'm talking about. So the distributive property can be shown mathematically like this. The problem with this demonstration right here and the distributive property is that it's missing one of the crucial elements that is almost always used with the distributive property, and that is rainbows. Bam, just like that. There's 2 rainbows right there. And some of you guys know, yeah, double rainbows have been known to make full-grown adults cry, and then it goes viral. So there's a double rainbow for you guys. And one thing we need to remember about the distributive property is that it's multiplication. Multiply, all right? So whatever you are distributing into that set of parentheses is being multiplied. Like in this case, the A. It's A times B plus the A times C. Okay? That's the distributive property, and we're going to apply this in these types of equations. Now, the nifty thing about distribution is that it doesn't need to be applied to 2 terms specifically. It could be applied to only one, like we would in this case, or like we may see in the future, 3 or 4 terms as well. So, like in this one, like this, the last one we showed the double rainbow, this one only gets 1, right? So it's, and by the way, it's important to remember what multiplication is. Multiplication is telling us how many sets of something that we have. So and I'll explain more about that later. But this one is saying that we got 4 groups of 8x, you guys. Well, 4 groups of 8x means that you got 8x plus 8x plus 8x plus 8x. Now, I don't want to write that because I'm a lazy math guy. And multiplication is supposed to shorten that for us anyway. So it's 4 times 8, which is 32 x's. It's 32x, you guys. And that would be distributing that 4 right there. Now, in some cases, you'll see letters being distributed. In which case, now I would say, well, I got 5 times n times n times m. And we could simplify this by combining the n's into an n to the power of 2 right there. Because there's 2 n's being multiplied. Okay? So this would be simplified on the green, and 32x would be simplified for the purple. Now, it is possible to distribute, just like we saw in that, I guess, that abstract example with the A, B, and C business. This is the type of distribution that we should see more often than not, where we're distributing a number into a set of parentheses, like this 12 in this case. So I start out, I distribute the 12 to the A, and remember, it's always multiplications, so it'd be 12 times A. Now, the next set of multiplications would be 12, and I say this is times negative 4, you guys, because again, that term itself is considered negative 4, and we take care of the operation after we multiply here. So just simplifying this, right, 12 times A, it's just 12A. I can't really simplify that anymore. On the other hand, though, 12 times negative 4 would be negative 48, right? So I write it as negative 48 like this, as though the 12a isn't even there. But then, putting it right next to it indicates that it would be finally 12a minus 48 as an expression. And this now is simplified. Well, like I said, sometimes we have to distribute this into 3 terms. It could be 4 or more, you guys, but distribution is not limited to any number of terms. So let's go ahead and distribute this into this set of parentheses. In fact, let me make that bigger. All right, let's distribute this negative 3. Again, I'm going to start with this 2x, and that's a positive 2x right there. So it'd be negative 3 times 2x, or negative 3 groups of 2x, which would be negative 6x. You guys are going to have to tell me if the colors make it more confusing, but I'm going to distribute the negative 3 now into this negative 9, which again would make negative 3 times negative 9 right there. And negative 3 times negative 9 is positive 27, but again I'm going to show it as plus 27 in the expression. And then finally distributing the negative 3 to the 4z right there, so that'd be negative 3 groups of 4z. Negative 3 times 4z makes that negative 12z. Now, there may come a time where the order of these is important, but it's not to me right now, okay? So I'm just going to leave it like this. Negative 6x plus 27 minus 12z. And be careful, because in our brain sometimes we get so used to simplifying things that it's like, dude, you know, I'm going to start combining that negative 6x with the 27 and negative 12z. You can't, because these are not considered like terms. At this time, after this simplification, I have 3 separate unlike terms. Since the negative 6 has an x, right, and the negative 12 has a z, they're considered unlike terms because the x and z may represent something different. So again, this goes back to, you know, like, it's like saying you got, so it's like saying you got 6, can you guys hear me? Yeah, so it's, oh, sorry. I don't know, technology, man. But yeah, this is, it's like saying you got 6 apples and 12 oranges. I mean, when you combine them, what do you get? Well, still 6 apples and 12 oranges. It wouldn't mean that you have 18 apples or oranges. You could say fruit, but that's a whole different story, okay? So yeah, I cannot combine the x's with the z's because they are different letters or variables in this case. So just real quick, again, we need to remember that when we're doing this with equations, that the actual solution to an equation is going to make the equation true. So when it says solve or solve for x, it really just means that what value of x is going to make that equation true, a true statement. So here's our famous and lovable principles of equality again. So again, this is just saying if you operate on an equation, if you're going to manipulate it, whatever you do to one side of the equal sign, you're going to do this to the other side as well. You have to do it to maintain equality. Now, on problems like this one, it says solve the equation 7x minus 13x minus 5x equals negative 4 minus 45. Now, some students like to say, well, I'm just going to put a line through that equal sign so I don't get the two sides mixed up. And if that's you, that's fine. If it's not you, that's fine as well. But I will look to the left side of this green line now and see if there's any like terms that I can combine. Why did I choose the left? Well, it's only because I usually am it's my habit. I start on the left. If you wanted to start on the right, that's fine. And I see that each of these terms have x's like this, right? So in terms of x's, I got 7 x's, I got negative 13 x's, and I got negative 5 x's, which really would come out to negative 7 minus 13, and then that's a minus 5 right there, which, if I am doing that right in my head, comes out to negative 11 x's. So combining all of these x's right here gives us negative 11x. Now remember, that green line represents where the equal sign is. And I've combined all the terms on the left side of that equal sign, so I turn now to the right side of the equal sign, where I've got negative 4 and negative 45, which I need to combine. And they are like terms because neither of them have x's or letters. These are considered constants. So negative 4 times minus 45 would give us, that should be negative 49 right there. Yeah, that should be good. And now we've simplified this now into a one-step equation where what we really want the coefficient of x to be is a 1, not negative 11. So again, we go back. How do I change a negative 11 into a 1? Just divide it by itself, you guys. Divide both sides by negative 11, and I'm just going to keep this as a fraction, by the way, 49/11. X equals 49/11. All right? So there's that. So I'm going to check this, right? So I'm going to say, well, what happens if I replace the x with 49/11? So I'm going to plug this into my calculator as 7 times 49 over 11 minus 13 times 49 over 11 minus 5 times 49 over 11. Now my calculator gave me exactly negative 49, but I need to check the right side because I did it in my head, and I tend to make mistakes when I put it in my head. And I get negative 49 again, so both sides are showing that they're equal to negative 49. So it looks like we did this correct, and again, I can now box it in with confidence. Now let's go ahead and solve this one. We got negative 5x minus 7 plus 7x equals 15 minus 3. This one's a little different, right? Because, and yeah, you can draw your line through the equal sign like that. And I usually use this upside down T business. But even before I were to do that, I should be looking to simplify this equation by combining the like terms, such as combining the x's right here, right? So in terms of x's, I got negative 5x's there, and then I also have a positive 7x's. And when I combine those, I end up with positive 2x's. Now we got this negative 7 here. There's no other like terms on the left side of the equal sign to combine with that negative 7, so it just stays negative 7. So we reach the equal sign right there. And next I see I have these two terms on the right side of the equal sign that I can combine. 15 minus 3, 12. So this looks now like a two-step equation, which we should be pretty used to at this point. And I need to isolate those x's, the two x's. I don't want them added or subtracted to anything, so I got that minus 7. I need to get rid of it by making a 0. So, as usual, just add it to itself or add its opposite. And I got plus 7 now on both sides of the equal sign, which does zero out that negative 7, which leaves me now with this just 2x equals 12 plus 7, 19. Now we've reached the one-step equation point where I've got to divide both sides by the coefficient in order to make 1x. 1x in this case equals 19 halves, which would be 9.5 it looks like. But again, I should check this in my calculator, right? So I'm gonna plug this in, negative 5x, well not x, 19 times 19 over 2, minus 7 plus 7 times 19 over 2. And it gave me 12, and we've already seen that 15 minus 3 is 12. I feel pretty confident about doing that one in my head. So it looks like our final answer is actually 19 over 2. Yeah, of course, we should have planned to see some distribution in this also. Well, let's get to it then. So distributing, in this case, it's only the 7, by the way. And I'm only distributing it inside the parentheses because it's negative 7 groups of x and 12. This is not negative 7 groups of 364. So please do not put a rainbow on that 364 right there like that. All right, we want to avoid that because we're only distributing it into the parentheses. And negative 7, again, times x would give us negative 7x's. But then we got negative 7 times 12, which is negative 84. So the rest of this remains the same because, well, the plus 364 does anyways. Okay. And I'm just rewriting this because I want you guys to focus on the distribution by itself for now until you guys feel more confident in your ability to do more than one operation at the same time. Because I could have combined that 13 plus 15 right there. But again, I'm separating it right now because it's not distribution in that case. So whatever equation you see, you should always be looking to distribute first, almost kind of as an order of operations thing, because it is multiplication before we look to add or subtract, which is how we combine like terms. So I did the distribution on that, and I've simplified this now to negative 7x minus 84 plus 364 equals 13 plus 15. But I got like terms that I can combine, right? Like this negative 84 plus 364. So what the heck is that? Negative 84 plus 364, 280. Let's put that in the calculator. And then also the 13 plus 15 on the right side of that equal sign, right? Which is 28. So now I got this negative 7, let me try that again. Negative 7x. Positive 280 equals 28 right there. And yeah, we're looking at a two-step equation now. So I'll extend this line a little bit like this. And I know I want to isolate my x's, so I got to get rid of that 280 right there and zero it out. It's a positive 280, so adding its opposite is the same as subtracting it from itself. 280 minus 280, that's going to give us 0. And then 28 also minus 280 as well. So that zeroes out. I can drop the negative 7x right here. And I've got 28 minus 280. So that's a negative 256. At least my calculator says. So I got negative 7x equals negative 256. There's a one-step equation finally, where all we need to do is divide both sides by the coefficient of x, which in this case is negative 7. So x equals, let's see what that gives us on the calculator, in case it goes into it evenly. Nope, it doesn't. So it looks like it's just going to be that should be a positive. Yeah, please. There we go. There's a good example of, checking your work, making sure you can read your handwriting. I'm only slightly embarrassed. Oh. So we got this negative 252, and putting now into the calculator, you're right, negative 252 over that negative 7 is going to give us a positive now. That's a 36. And we got x equals 36, but again, I'm just going to go back and check. And with the calculators that I've recommended and the calculator that I'm using right now, I can type this in exactly like I see it. Negative 7, parentheses. But again, instead of using the x, I'm going to type in 36. And then plus 12, I'm going to close that parentheses and then add 364. And this gives me 28, which is what we got. So This is what you can see on my calculator right there. I don't know if that helps, but it confirms right there on the right that the answer was 28, which is what we figured before. So again, this just allows me to box this in with great confidence. So another equation, again, look, same principles pretty much every time, you guys. It's just, yeah, the size of the question or the equation just, it may get bigger. But hopefully that doesn't cause any problems as long as we have, and that we know that we can distribute, we can combine like terms, then isolate x's, and then divide by the coefficient. That's pretty much all it's going to be all the time. So on this one, again, just looking at it, I see that I've got this parentheses right there. So I know I'm going to need to distribute. Now we got to be careful with what we're distributing on this one, because a lot of students, if we don't have the background for it, we would look at this and think, well, you know, I'm just going to distribute 5, right? So 5 times x is going to give us 5x, and 5 times 3 is 15. But remember, a term is going to take the operation to its left as its sign. That means that this is really negative 5 that I'm distributing into the parentheses. So that's negative 5 times x, which is just negative 5x. And then I also have negative 5 times, that'd be positive 3, which is going to make that negative 15. So overall, it ends up being negative 5x minus 15, but I'll include all those other terms. So I got 14 minus 5 equals, there we go, 10 minus 5x minus 15 plus 7x, right? So now I would look on either side of the equal sign and just see, because I've done the distribution, if there's any terms that can be combined, any like terms that can be combined. And sure enough, on the left, I got this 14 minus 5, which would combine into a 9. And on the right side of the equal sign, there's 2 sets that I can combine, right? I've got my constants, 10 and negative 15, which combine into negative 5. And then also the x's, which I can combine. They're also like terms. That's an x right there. And negative 5x's plus 7x's is positive 2x's. So I have now a simplified equation. 9 equals negative 5 plus 2x. Now it doesn't matter which side the x's are on. Like right now our x is on the right, which may seem a little unusual because we've seen most of them on the left side of the equal sign. But they can still be isolated pretty quickly if I just get rid of that negative 5 right there. So I'm going to zero it out by adding 5 to both sides. Alright, now doing this, of course, zeroes out those 5's, which is what I wanted. And 9 plus 5 is 14. So I got 14 now equals positive 2x. Yeah, I just dropped that 2x right there. And I don't want 2x's, I want 1x. So how do I make that a 1x? Just divide both sides by the coefficient, which in this case is 2, making that 1x. 1x equals 14 divided by 2 is 7. So that's what I think the answer is. But again, I'm going to go back to my calculator, which I'm just going to replace the x's with 7. So 10 minus, I know the left side, 14 minus 5 is 9. I feel pretty good about that. But the right side with the parentheses and stuff is different. 10 minus 5, parentheses, x, but now x is 7, plus 3, close my parentheses, and then plus 7 times, well, 7. So this is what I got in my calculator, you guys, right there. And as soon as I push equal, it's going to show me 9. And now I know that my answer is correct. And again, it allows me to box this in, and I feel pretty good about the work that we did, even though you guys are seeing I've already made a mistake today. But having corrected that mistake, I feel pretty good about this one.